I'm a vintage motorcycle mechanic at heart, and just about any vintage motorcycle mechanic will tell you that after about 30 years, you can guarantee a brake rebuild with hydraulic brakes, if not having to replace the entire system. Hydraulic brakes just don't last very long. Henry Ford in the 1920s was notorious for his reluctance to accept hydraulic brakes on his cars. His marketing slogan was, "The strength of steel from pedal to wheel." I'm going to modify that slogan and say the endurance of steel from pedal to wheel. Mechanical drum brakes are an excellent survival tactic for vintage motorcycles. I can take a bike that was made over 100 years ago with cable-operated mechanical brakes, get on it and ride around, and the brakes perform almost the same as they did when that motorcycle was new. Given that one of the single most important facets of the design of the Magnolia 4 is the century concept, that is, a motorcycle is designed to last for 100 years, hydraulic brakes just weren't going to make the cut. Design from first principles dictates that we analyze each individual system to see if it matches up to our requirements. Since hydraulic brakes don't pass the 100-year test, this means a return to cable-operated drum brakes. The first thing that you'll notice about the Magnolia 4 wheels is that they have a lot of surface area. Drum brakes do have their issues, and the biggest issue is thermal management. Ettore Bugatti, clever man that he was, understood this. That's why the wheels of his masterpiece, the Type 35, are cast aluminum with an incorporated brake drum. He understood that the wheels are actually the greatest heat sink on a vehicle. The wheels of the Magnolia 4, you'll notice, have a lot of cooling fins. That means surface area to help cool the brakes. But we're also using the wheel itself to cool the brakes both through convection and conduction. These are actually forced induction brakes. Understanding that the drum should be part of the wheel to conduct heat directly into the wheel means that I have to start all over and design a set of wheels to go with our drum brakes. Let's take a tour of our wheel and drum brake combination. The first thing you'll notice is that this is obviously a dual leading shoe front drum brake. I considered doing a 4 leading shoe, but one of the important factors of the Magnolia 4 is the reduction of mechanical complexity. And while 4 leading shoe work really well, they're really difficult to set up and keep in perfect mechanical operation. 4 leading shoe mechanical drum brakes are really difficult to keep tuned, whereas a dual leading shoe is much, much simpler. The other thing you'll notice is that there is an air scoop, like you see on a lot of vintage style drum brakes, but our air scoop is actually facing backwards. The front of the motorcycle is this way. Our scoop now transfers to the inside of the wheel with this very strange shape. This shape actually interfaces with these vanes on the inside of the wheel. This is actually forced induction cooling. Cool air is drawn from the backside of the girder blade, the trailing edge of the backing plate, and then forced into the wheel. We then have a series of ports on the other side of the wheel to vent not only hot air, but also brake dust, because brake dust turns into a dry lubricant. Like most drum brakes, we have a tongue and groove, which is a water excluder around the edge of the wheel. We also have conventional brake shoes, and we'll be doing a lot of experimentation once we're in production on different compounds. Another interesting fact about dual leading shoe brakes is that you want to have the shoe lead with the cam. That means that the wheel rotation is this way so that the cam is the first thing that is encountered. That goes here and here. You'll notice that on the Magnolia 4, we've got a brake drum on the right-hand side on the front and on a left-hand side on the rear. Well, that means that relative to the backing plate, the wheels are turning in 2 different rotations. The front is turning clockwise, the rear is turning counterclockwise, which means that this backing plate has to be designed in such a way that it's modular. And you can see it here. These mounts for the trailing edge of the brake shoe are actually modular. They can be run here or on the other side. These parts are bilaterally symmetrical and can be run either way to compensate for the direction of the wheel. We can also tune mechanical drum brakes by the profile of the cam itself. In other words, a mechanical form of tuning progressivity of your brake. Now, to increase feel, there are a couple of things that I've done. The first is replace what would normally be a bushing on the cam with a double row needle bearing. This is my favorite bearing, 28mm OD, 15mm ID, and this bearing is sealed and can handle some thrust load. Now let's talk about the actual braking surface itself. You'll notice that our brake liner here is pressed in to our all-machined billet wheel. Another problem with drum brakes is that they are inherently asymmetrical. In other words, you have one end that's open so that you can load in your backing plate, and the other end is closed off to provide support for the wheel bearings. Now, if all of this was made out of a single material, you would have an asymmetrical piece of cast iron. That piece of cast iron is going to expand conically, which means that you will have incorrect contact between the drum surface and the brake shoe itself. What I've done is make our press-in liner mount radially into the wheel. Cable selection becomes quite an issue as well. Traditionally, cables are spirally wound, but the new generation of linear cable opens up all sorts of possibilities. If you think about it, a spirally wound outer cable turns into a giant spring that reduces feel. Linear cable provides a more direct mechanical action on our moving parts. And of course, there's the all-important wheel size. I've chosen to run 1919 front and rear on the Magnolia Special because large wheels go over road imperfections more smoothly than smaller ones. 19-inch wheels also have a beautiful proportion and pay homage to those wonderful motorcycles that we all love so much. Brough Superior, Vincent, Henderson, and Ace. The 19-inch wheel is just delightful in proportion. When it comes to weight, our wheels are actually 10 pounds lighter than a stock standard Harley-Davidson 16-inch wire wheel with a steel rim and single rotor. I hope you've enjoyed this presentation of an all-new drum brake design and a wheel to go with it. Up next are going to be suspension components for the Magnolia 4.